And I think that is in the nature of the problem with boundaries in complex systems. In Newtonian systems, you have nice clear boundaries, right? They're kind of walls. And that fits in very nicely with Aristotelian logical categories, right? They're very clearly bounded.
The logical representation of the law is incredibly helpful as a way to learn, because as lawyers and law students, we're trained to write outlines, and that is it is a logical representation, and that can convert into code, an express language, an express computational language of the law.
Hydra introduces the concept of isomorphic state channels. This is to say it reuses the same ledger representation to yield uniform off-chain ledger siblings. Smart contracts can now be run on the mainnet. This ushers in a new era of development on Cardano.
In complex especially complex adaptive system, because of these feedback relationships, they are more like membranes. The boundaries are porous. They're more like membranes whose behavior is governed by a set of rules or algorithms. Instead of having walls, you've got passports.
The challenge for any permissionless blockchain is the ability to scale and achieve any kind of throughput required to support applications in the real world, including payment, identification, gaming, and mobile services.
In practice, with Clear Access IP and with the Codex Smart Prosecution Project, I've found that the best approach is actually a hybrid approach. That logic plays a very important role, but there's also other computational tools that are necessary. Smart contracts, generally speaking, relate to contracts executed oftentimes on the blockchain, or Ethereum is also a smart contracts platform.
In design, we're used to extreme levels of control over form and the shape of a thing and how it behaves and how it functions. And that's something we've inherited from the Industrial Revolution.
So we can embed these rules into smart contracts in order to enable the agents to cluster in the most productive way and optimize over a goal.
So this use of computational law refers to one particular approach to legal automation, and that is a rules-based approach to legal automation. In this way, you represent the law and the meaning behind the law in ways that a computer can understand, and the computer comes to legal conclusions about outcomes using deductive reasoning.
And as I mentioned before, this can be encoded in DAOs. And once we encode them, so it's not encoded once and for all. So if I have a certain goal, I can run a simulation in which, of course, this is a physical world. We have the agents in the digital world modeling the physical world. So we have this digital twin of the world, and then we can run simulation across all these agents and reorganize our structures, our organization. They can be even our stores or offices, so that when we come back to work, we optimize not only for productivity, but we optimize also for health. Then we can have a different restructuring of our physical world, which the software would enable.
I would say that computational law requires us to really think broadly about what the problems are and think broadly about the approaches.
But it feels that there's certain constructors for models that nature is reusing and recombining in different ways, and that sets of constraints, or always in a different incarnation. But like for example, the currency system in mitochondria. And it's amazing. It's just mind-boggling. And I'm wondering if there's, if we could define that language of models of complexity or patterns of complexity, if we would be able to have a different vocabulary to do business with also.
The flows can lead to cascading failures, but on the other side, if we plan the flows for the critical hubs to actually not have that kind of weight and criticality, we can design robust networks. So this balance, the topology dynamics, is pretty crucial when we want to control the flows through networks in order to, like, it can be flows of people, like interactions, or flows in case of people interactions that can accelerate or decelerate. So we can optimize the networks.
This is a standard epigenetic landscape that Conrad Waddington formulated, I don't know, 50s, 40s, I don't know. But imagine if you only thought in terms of energetic power relations. All people would think of is pushing the ball here to counteract gravity and try to get it over this hump. But if you look at the right-hand image, you realize that it's all these underlying constraints that are creating the landscape, that if you were able to adjust the constraints that produce the landscape, you would change the topology of the landscape, and the system might go in the direction that you wanted it to.
And that this version of computational law is becoming more important these days because we're seeing a lot more law embedded in technological systems.
So the suggestion that complex system has is you're better off trying to manage an ongoing complex system by focusing on the constraints that underpin or subtend the obvious surface phenomena than it is to try to change it through powers.
Is following exactly how nature is optimizing for robustness. So this process of organic governance, just as you have seen with the ants optimizing for the path to the food and from the food to their workplace, we can have these norms and rules in our institutions emerge from the individual agent interactions.
With nature, there's this diversity that happens without necessarily having a reward function, right? This is good or bad. Things just happen, and some of them happen to have wings, and some of them happen to have scales, and you end up with this incredible potential for diversity. So I think the future of design is in that soft control, is in the ability to design highly controlled systems that enable the loss of control, and creativity is very much part of this.
One thing about smart contracts, though, and the biggest development that I think has happened here is Ethereum. Ethereum is a blockchain tool. All blockchain is a ledger. It's a ledger of hashes of things that have happened on the ledger. Ethereum allows you to embed information into that ledger. So it's not just a transaction of Bitcoin, but it can be a transaction of something containing many terms potentially. And that's what makes smart contracts in that context really attractive from a legal tech standpoint.
Last 2 years, there have been at least 4 books that have come out about fungi, and, for example, things like lichen, where there is symbiosis between kingdoms. A fungi is not in the same kingdom, biology kingdom, as a plant. And yet the mycorrhizae that basically sustain the biosphere's sequestration of carbon and nitrogen, that's a symbiotic relationship. It's not at all a competitive relation.
Right.
So I am wondering whether this notion of Darwin's of red in tooth and claw, and another interesting thing in Darwin, survival of the fittest, we tend to think of it as a competition in a race. The one that's faster is going to win and the others are going to lose. The way Darwin and that period of time thought of fittest is that you go to a tailor to be fitted for a new suit of clothes. It's like a fitting. I have to go to a fitting. I'm being fitted by my tailor for a new suit of clothes. What that fitting is a process of co-adjustment between the actual constraints of the cloth and the actual constraints of the body and the movement. I think that thinking in terms of enabling constraints to facilitate new symbioses, instead of putting a moat in front of a medieval castle and a wall, right? You start using passports. But what that means is you've got rules that regulate the functioning of those membranes or those boundaries.
Because creativity is all about letting go and beginning again and beginning again and beginning again. And when you cannot let go, you cannot be creative, and you can't find novelty. But I think that letting go is a moment that enables empowerment, agency, creativity, emergence. And they're all connected. They are sort of associate themselves with definition of destiny or the inevitable.
Do you think there's like a vocabulary of model patterns that's universal?
I suspect that if there are such patterns, it has to all bottom out in thermodynamics. So whether it is ATP energy flow or electrical or or nutrients or whatever, the pattern must facilitate energy flow better than not having that pattern.
Yeah.
And some patterns may be better than others at facilitating energy flow. So over time, you get even abiotic selection of the more efficient, effective thermodynamic patterns throughout the cosmos, which is why you get spirals of galaxies, which is why you get, that sort of thing.